Adding and subtracting vectors mathematically or by components. It's probably the preferred method over graphically. Graphically is only a quick way to do it when you just want an approximate answer, because it takes too long to do a nice diagram with a protractor and a ruler. This really doesn't take that long as you have the components all figured out. Now, we figured the components out earlier. Actually, I have to figure out vector A is 10 meters, not 4 meters. So if I look back at my notes here from yesterday and write down all the components. So there's all the components figured out properly to the first decimal place. And the negatives are very important when you're talking about components. When you're talking about actual vectors, never use the negatives on the actual vectors, and never use the negatives when you plug into the calculator, because all of that is taken care of with the diagrams, the little sketches, the component vector sketches. But for example, this just follows the rules of arithmetic and algebra. If I want a plus b plus c, what I first need to do is to find the resulting x component of my answer. R sub x is going to be a sub x plus b sub x plus c sub x. And you could have 5, 6, 7, 8 vectors. And it's just the same method. So in this case, r sub x will be 7.7 plus negative 2.9 plus negative 8.0. So the x component of my vector, resulting vector, will be negative 3.2 meters. Very important. Same thing for the y component now. Just the resulting component, y component of my summation of the y components will just be 6.4 plus 4.1 plus 0. So my y component is easy. It's 10.5 meters. Those are my components of my resulting vector. So now I want to construct the vector itself, just like we did yesterday. I can draw a little quick sketch, which is always good. And my components, I'm going to have this component, which is 3.2. I don't need to put the negative on a diagram. I've already indicated the negative with the arrow. That's 3.2. And then my y component is 10.5. So my actual vector, I'll use a black one, points in that direction. That's my resulting, that's what I'm looking for. And to figure out the magnitude of r, I use the Pythagorean Theorem. In other words, r squared equals 3.2 squared plus 10.5 squared. So r equals 11.0 meters. Wow, when I did the diagram, I got like 17 or 18 meters. My diagram must have been way off. Don't worry about it. Just get the right approximate directions on the vector diagrams. But I do need a direction on this. And I will use a reference angle here. Let's try to get this angle right here. To find that angle, I can use the tangent of theta for that triangle. Tangent of theta equals the 3.2 over 10.5. 3.2 over 10.5, which gives me a theta of, theta is going to equal 17 degrees, which is past the 90-degree mark, so it's 90 plus 17 would give me 107. So my answer would be the resulting addition of those three vectors is 11.0 meters at 107 degrees, and that would be my answer. I think I was pretty good with my angle on that sample problem, but my magnitude was way off. All right, let's do another one. Let's do a minus b. I'll have to do that on the next page. All right, example number 2. Vector A minus vector B by components. So once again, our resultant, call that r sub x, will be a sub x minus b sub x. So really pay close attention to the negatives. So in this case, r sub x will be the a component, 7.7, minus a negative 2.9, which results in really addition here. So r sub x is 7.7 minus a negative 2.9, which gives me positive 10.6 meters. R sub y is going to be a sub y minus b sub y. So r sub y equals 6.4 minus 4.1. So r sub y is 2.3 meters, both positive. So that vector is going to look something like this. If I draw a little sketch, always draw a little sketch. My components are as follows. Draw those in blue. X component is pretty long, 10.6 meters. My y component is 2.3 meters, a little shorter, 2.3. So my vector itself is going to look like this. Call it r. To figure out r, we use the Pythagorean Theorem. R squared equals 10.6 squared plus 2.3 squared. Therefore, r equals 10.8 meters. And we need the angle here. It's going to be a pretty thin angle there. Tangent of theta equals 2.3 over 10.6. So theta equals 12.2 degrees or 12 degrees. Therefore, my resultant is 10.8 meters at 12 degrees. That's my resultant. Subtraction A minus B. All right, one more example on the next page. All right, the last example. I know the sheet says B minus C, but I'm going to do C minus B. I did this one before graphically, so I'm going to do C minus B. C minus B. All right. So it's just going to be our resulting x component will be C sub x minus B sub x. So that is, if you look at the components on the previous page, C sub x was negative 8.0 minus B sub x, which is negative 2.9. A lot of negatives there. So r sub x ends up being negative 8.0 plus 2.9, which is what? Negative 5.1 meters. Then r sub y is C sub y minus B sub y. R sub y is therefore C sub y, which is 0, minus 4.1. R sub y is negative 4.1 meters. All right, put this vector back together. Always draw the little diagram. Draw the little diagram for your vector. Looks like this. The components, I'll do those in blue. R sub x is negative 5.1. Okay, that's 5.1. Don't need to put the negative on there. The arrow shows the negative direction. R sub y is negative 4.1. So the vector itself will look like this. Draw the actual vector. It's black in this case. R, that's a resulting vector. So we'll need to use the Pythagorean Theorem. R squared equals 5.1 squared plus 4.1 squared. So R equals 6.5 meters. All right, and the direction, I'll pick, well, I'm going to find this angle right here, but I could also go in the negative direction, but I'm going to get that angle right there. Tangent of theta is 4.1 over 5.1. 4.1. So theta, using inverse tangent, is 39 degrees. But that's from the negative x-axis, so I'm going to take 180 degrees plus that, which gives me what, 219 degrees? So 6.5 meters at 219 degrees in the positive direction. That would have been equivalent to a negative 141 degrees to get to 360. All right, so that's vector subtraction and addition by components. That's the preferred method. We'll be doing a lot of problems like that.